For this 3x3 system of equations, I'm going to be using the elimination method. By looking at the x's, I notice if I add the bottom two equations, the x's will eliminate. And furthermore, if I multiplied this one by a 2 and added it to the top equation, I could also get x's to eliminate. Sometimes what I like to do to keep track of work is I call this equation A, B, and C. And so the first thing that I'm going to do is add equations B and C. So these x's would cancel. There would be 8y and negative 5z. On the right hand side, negative 28. And then use equation C, but multiply by 2. So 2 times equation A, 2 times equation C, and add that to equation A. So this would become negative 2x. Combined with that is nothing. This one multiplied by 2, so we'd have 6y. Combine it with that, so there's 5y. Multiply this by a 2, so we've got negative 2z. Together with a positive 3z is just 1 positive z. And then 2 times this is going to be negative 18. Added to that is a negative 1. And then we can use substitution or elimination method with the y and the z. With this one, it looks like I could solve for z pretty easily right here. Z is equal to a negative 5y, subtract 1. And then substitute that into the top equation over here. So the top equation would look like 8y minus 5 times what we just got for z, and then equals a negative 28. The next thing to do is distribute that negative 5, so we're going to have an 8y, and then a negative times negative will be positive 25y, and then a 5 times a 1, again, two negatives make a positive, and then it equals negative 28. So this is a grand total of 33 y's. If you subtract 5 from both sides, this is going to be negative 28, subtract 5 makes negative 33. And so once we divide, we get y equals a negative 1. Now to find z. So go back to, you can use any of these equations, but this one's already solved for z, so it'd be easiest to substitute what we just got for y right here. So then z is equal to a negative 5 times negative 1, subtract 1. So that's going to be a positive 5 minus 1. Z is equal to 4. After we've got that, go back to any of these equations that have an x in it and substitute what we got for y and z. So I'll just use this one. Negative x plus 3 times what we got for y minus what we got for z, and that equals negative 9. So this is going to be a negative 3, and a negative 4 is negative 7. And then add 7 to both sides. Well, if you add 7 to this, it's going to leave negative 2. And then multiply or divide by negative 1 on both sides. Get rid of the negatives, so x is equal to 2. And then finally, the point in space where these three planes intersect is at x equals 2, y equals negative 1, and z equals 4. But I've got a way in the graphing calculator to check. So it's done with matrices. So right here, under the x negative 1, there's matrices. So go second matrix, move over to edit. If you don't have these numbers, don't worry about it. We're going to put those in right now. And then enter. And the size of this is 3 rows and 4 columns. The x's, the y's, the z's, and then the constants. So 3 rows and 4 columns. 3, enter, 4, enter. And then enter this. You don't have to put the x, y, and z. It understands that. So 2, negative 1, 3, and 17. And just hit enter each time. 1, 5, negative 4, and negative 19. And then negative 1, 3, negative 1, and negative 9. Okay, now quit and go back into matrix and get over to the math column and go down to what's called reduced row echelon form. The calculator abbreviates it as RREF. And then go back into the matrix and under names, get the name A. So then it will take our matrix right here, basically do the elimination method for us, and hopefully we got this right. And sure enough, the first one is for X, the second one's for Y, and the last one's for Z. We got it.